Hello everyone and welcome to another video from Carl's Tech Shed. Well, what I've got for you today is a rather unusual piece of equipment. This is a pay terminal from a post office. These were used in the mid-90s before PayPoint had a contract with the post office to accept payments. This was very kindly bought for me by my girlfriend Holly over there, and I'm filming this on her kitchen table where I'm going to be doing a teardown of this, and we'll see what's inside it, and in a moment I'll power it up and show you what it does. Not that it does very much, of course, because it seems to have some sort of fault with it, but it still does some sort of self-test, so I'll quickly let you have a look at that. Right, well, I'll power this on to let you have a look at it. But first of all, the power switch is in a very unusual location. It took me a while to find it, but I eventually found it inside the unit underneath the dot matrix print head. So if we just poke down in here, as you can see, it's running some sort of self-test sequence with the dot matrix head. If I can pop that back into place. Now, there's a very dim glow coming from the LCD. I'm not sure if you can see that, but it's a very dull glow. It's not as bright as it should be, but there's no characters on the LCD as there should be. But this unit will eventually start to tick over, and you'll get a dot matrix feed. And if you start pressing the feed button after a few seconds, it will begin to attempt to feed paper through it. But unfortunately nothing comes up on the screen and none of the other buttons are responsive, so it may be just a firmware issue. Maybe one of the EEPROMs has been wiped or something like that, but nevertheless I don't think that it's worth repairing because it would be quite difficult. If we press the feed button, we should get something now. There we go. So as you can see, it's doing something, but unfortunately there's nothing displayed on the screen, and there's no controls anywhere on the unit to adjust the LCD. So I think it's time to take it apart and have a look inside. Okay, well, now that I've opened it up, as you can see, we've got a series of boards in here, and it's quite complex really for what it actually does. If this were modern, everything would be done on a small board, probably no larger than this board over here. But if we start over here, this is the flip side of the front panel. So as you can see, this has the main microcontroller, which is a PC chips 14 megahertz processor. This emulates something similar to an Intel 8286 or 386 series processor. We've got a small SRAM chip here, which is 64 kilobytes. Up here we've got the main display controller, which is made by Hitachi, and then we've got a serial interface down here onto the main board. Now over here we've got the modem, which plugs into this which connects into this cable here, which then goes out to the casing and then into the phone line. And as you can see here, we've got a series of controllers here. These are Rockwell controllers for the modem. There's one here, and there's another one down here. These are all serial interface chips, so these would link into the microcontroller using a serial port, which is controlled by this IC here. This actually has native RS-232 and IEEE 1284 support, so this would actually support an external printer. Now I've actually removed some of the cables which were connecting all of these ports together, just so that you can see them a lot easier. But this one here was the external printer port. We had two RS-232s here, another one here, and there's another one on the underside of this board. But there was also a board over here which contains another microcontroller. This time it's a small 80C32 processor. I think this is going to be controlling the card payments and also the dot matrix printer head at the top. Because if you look just under here, we've got three separate types of card payment acceptance. We've got a traditional mag stripe at the top just here. we've got something similar to a chip and pin card here, but it wouldn't actually require a pin number. It's just extracting the card details from the card and authorizing them online. But we've also got an unusual payment option here. I'm guessing this is something similar to perhaps maybe like a gas key or some sort of proprietary payment key, which would be used by the post office when this was in use. But if I remove this board here, now on here we've just got a small amount of power management here. We've got a couple of capacitors, small wire wound resistor. We've got a capacitor over here and a small MOSFET. What's interesting about it though is there's an internal RJ11 port which is completely unconnected, so maybe in an earlier revision this would have been part of the modem as well, rather than having the modem on the separate board here, because there are some unpopulated component space here, so you would probably have the modem block here rather than on the other board on the other side. Now we've also got a small EEPROM here. This is 256 kilobits of data held on this, so this is probably holding some firmware to operate the dot matrix printhead, which I'll show you in a moment. Now if we remove this board from here, as you can see we've got a couple more serial ports here. These were connected over to the other board via cables, so the ports are actually on the underside of this board. We've got another microcontroller here. This is 4 kilobytes of SRAM here, 4 kilobytes of ROM, which would have held the firmware for the device to boot up with. We've got a small dot matrix controller here, a couple of hex inverters, and if you can look carefully at the back, you can see we've got a massive bank of MOSFETs. There's 9 in total of these small MOSFETs. Each one of these controls a single pin on the dot matrix printhead, because these require quite a lot of power when they're operating. We've got another EEPROM here. I'm not sure what the size of this is, but I think it would be around the same sort of size, maybe 256 kilobits, something around that size. But what I'm going to do is I'm going to remove this, I'm going to unscrew this board, and I'll see if I can get this valve regulated lead acid battery out of here and have a look at this. Okay, well I've unscrewed all of the boards out of the chassis now, and I did remove that lead acid battery from this board here. It wasn't actually screwed in as I assumed, it was actually just held in with glue pads. I'm quite surprised at that because this system is about 20 years old, and from experience these glue pads don't usually last any more than about 5 or 6 years before they start to disintegrate. So quite surprised at that. This little card reader down here, there was a little mag strip reader which I removed, which is, where have I put it? Just under here. Unfortunately I accidentally tore the flex PCB when I took the small board out which was controlling it, but no matter. This is just a standard swipe card reader, so this was then going into a serial port on the board. Also, what I forgot to mention was that when I took this apart, I've noticed that this small proprietary style card reading device wasn't actually connected. It doesn't seem that there's any components on the underside of the board for this, but it looks like some sort of payment key or something like that. But there's no components, so it would probably have been an additional extra which they didn't actually include in this model. So yeah, that was maybe for a different revision. But this one's definitely connected, and so was the mag strip reader. One thing I forgot to mention about this board over here was that next to this EEPROM, there were also 2 small SIP packages, which are 256 kilobyte RAM modules. These are single inline packages with a staggered pinout on the bottom. There's also an unusual little riser board here with a small transformer on it. So I'm not quite sure what that's for, but I'm guessing that's something to do with the modem because it's in that vicinity. So I'll leave it at that. But the EEPROM over here, I've just noticed that it's got a chip's BIOS label just next to it. So it's quite possible that that was loaded with BIOS firmware for boot up. And they've just used an off-the-shelf EEPROM to hold that. But over here, I've taken the dot matrix print head apart, and I'll show you the board which was controlling it, and you can see those MOSFETs a lot more clearly now. So you've got the main power capacitor here, you've got a bank of MOSFETs and a bank of silicon resistors, silicon diodes on here, which are then leading up to the print head itself. I couldn't actually get into the majority of the print head because it's sort of a sealed unit, but I was able to get the top cover off, and you can see the small clutch mechanism that it's got for moving the print head across the page. But it's quite an unusual bit of kit. Quite interesting, really, to look at. It's got a small rainbow cable coming off of it to go down to the bank of MOSFETs to power it. I think what I'll do now is I'll remove this so you can have a look at the keyboard membrane and the LCD, which are just underneath it. Now, I've removed this so that you can see what's on it, but there's just a series of these Sanyo LC7942 ICs, which are LCD controllers, and then we've got a small serial data IC here. As you can see, you can either have a parallel or a serial data stream coming into this, and it's just a standard 4-line dot matrix LCD, but it's still quite handy, and you could probably even hook this up to an Arduino or something similar. This little yellow cable connected to it is just a power connector for the LED backlight. But just under here is the keyboard membrane. As you can see, there's no components on here at all. It's purely just a membrane connected by a flex PCB onto the main control board. But this was actually replaced on the 4th of August in the year 2000. So this has been maintained, I suppose. So probably wore out and they just replaced it. Well, what I'm going to do now is I'm going to take apart the barcode scanner which was connected to it, so I'll let you have a look inside that. Okay, well, this is the inside of the barcode reader which came with the post office payment device. This is just a standard RS-232 barcode scanner, but I thought I'd take it apart just to let you have a look inside. Now, as I said, this is connected by a 9-pin D-sub RS-232 connector, but unfortunately this has suffered some water damage at some point, so if you were to use this, you'd probably want to end up replacing that connector at some point. You've also got a 5-pin DIN connector, which would be used for maybe connecting a keyboard in series with this connector, so you could use a keyboard on the same port. All of these both connected into the barcode scanner using an RJ45 connector, which then plugs into this small socket down here. Now, the actual microcontroller for the barcode scanner is a Motorola MC68HC11 processor, which is a variant of the 68000 series processor which Motorola makes. This is actually still in production, but it's now made by a company called Freescale. We've also got an Atmel CMOS chip here, which holds 32 kilobytes of data, so this would just be the firmware to run the device. Now, if we go over here, we've got a small flex PCB cable, which goes onto the barcode reader board here. We've got a few ICs here. These are mostly just glue logic. There's a couple of hex inverters and shift registers, but nothing too special. But if we flip this over, we'll see that we've got an LED here. We've got a bit of power management here, but this connector here connects down onto the sensor array, which I'll let you have a look at now. We've got a series of LEDs here which would illuminate the barcode so that it could be read. This is then bounced through a mirror assembly this way up. The barcode is bounced from the front of it off the mirror here and then onto the image sensor. Now, this image sensor is actually manufactured by Toshiba. It's actually meant to be a DIP package, but what they've done here is, as I'll show you, they've actually decided to mount it on a flex PCB. So as you can see, there's a very thin line. I don't know if my camera is going to focus on it, but you can see a very thin line of silicon just in the middle there, which is the image sensor. It just picks up a single line of pixels, which would be the barcode. It then serializes the data and sends it through this flex PCB here into the reader board here. That's then decoded by the microcontroller, which is then on this board and turned into a machine readable code, which is then sent via the RS-232 port into the device. So, and this is the key part of everything. But I wouldn't be a bit surprised if this one or certainly a part very similar to this is still manufactured today, because barcode readers haven't really changed that much, especially if it's just for a standard two-dimensional barcode like you see on books and other products. So quite a useful bit of kit, really. Well, overall, that's the general teardown of everything I've got today. Well, thanks for watching, and hopefully I'll have another video up very soon.